Hello, Calculus 2. It's Belize Mathematic here, aka Brock, and today we're going to be going over some of your Exam 2 practice problems that I think could show up on the test. So, without further ado, let's get it started with arctan of x over 1 plus x squared. So, if you want to try this problem on your own, go ahead and pause the video now, work it out, and then come back if you get stuck. So, I'm going to start out by doing a u sub of arctangent of x because I know the derivative of it's going to have that 1 over x squared in the denominator. And the derivative of that is 1 over 1 plus x squared, or x squared plus 1 dx. And so then I'm going to rewrite my integral in the u world. Here goes my ESPN fantasy football notification. And our dx our du literally gets wrapped up into our 1 plus x squared dx, and that's all equal to du, and our u is in the numerator, arctan of x. So this is going to be our simple integral, and the antiderivative of that is u squared over 2, or 1/2 times u squared. And then we're going to replace that back into the non-u world, which u is arctangent of x, arctangent squared of x over 2 plus c, and that is going to be our final antiderivative for that one. All right, hope that was semi-easy, good start. Make sure you're remembering your plus c. All right, next question. Secant cubed x tan x dx. Pause the video now if you want to try and solve it on your own. All right, hope everyone that wanted to try it tried it, and if not, you can watch see what I do. So I look at both of these functions. They're being multiplied, so we could think to do some sort of integration by parts. I would pose that that's going to be really, really complicated and get ugly quick, seeing as the antiderivative of tangent in itself is pretty weird. And so I would like to suggest let's try looking at secant. Do we know the derivative of secant? I should hope we remember it. Okay, watch what I'm going to do here. First off, I'm going to rewrite this as secant squared of x times secant x. I just took out one from the secant cubed. I just took one of them out and stuck it right there. Times tangent of x dx. And so I'm going to make a u sub, and I'm going to make my u be secant of x. Why that? Well, if you remember back to Cal 1, the derivative of secant x is secant of x tan x. And we have this huge piece sitting right there, and we have two secant x's sitting right here. And so I'm going to rewrite my integral as the integral of u squared, and my du gets wrapped up onto the whole right side. And so picking secant x as our u is really, really helpful here. Okay. The antiderivative of u squared is just u cubed over 3. And replacing everything back into the regular world, we're going to get, our u is secant, so it's going to be secant cubed of x over 3 plus c. And that's going to be our final answer for part B. All right, part C. Hopefully everyone's seen this integral at some point, hopefully pretty recently. Okay, if you need to pause the screen, go ahead and do that for a minute. All right, let's get started. First off, I'm going to rewrite tangent using one of its trig identities as sine of x over cosine of x. Don't lose your dx. And from there, simple u substitution should be enough. I'm going to do cosine of x. I'm not sure if it'll quite matter. You could do a sine of x. It'll just look a little bit different, I think, in the end. But the derivative of cosine is a negative sine of x. And then we're going to look back up at our original problem, and we have a sine x dx on top, so we just got to move that negative over. I divide by -1 if you want to get our negative du to be sine x dx. And so now we're in u world. We got that covered, and we have a cosine in the bottom, so just 1 over u in our case. If you think to remember, one of your most common derivative or antiderivative rules is the natural log. And so 1 over u, the antiderivative of that is natural log. So negative natural log, absolute value of u plus c, and then we'll write that in the x world, which becomes negative natural log of cosine of x plus c. All right. Hope that one wasn't too crazy. Don't try to overcomplicate yourselves doing some crazy integration by parts problem when you might not have to, especially when there's not a product. I mean, you could think about this as sine over 1 times cosine, which could, I guess, lead you to believe to do a integration by parts, but let's try to hold off on that in that problem. But on a problem like this, I would think about that as a product. And so, again, if you're working it, pause the video, try and work it out yourself, and then come back and see how I did it. Okay, so hopefully you have come across my fun saying of Liate. It's a good way to pick what to use for u. And typically that's the one that gets the derivative, becomes a little easier. And so what Liate stands for is logarithmic, inverse, algebraic, trig, and exponents. And so whatever comes first in the sequence of Liate is what I'm going to pick for you. And so I look over at my two functions. I have an algebraic function and a logarithmic function. And so logarithmic is first. I'm going to pick natural log of x to be my u, and my dv, I'm going to pick x squared to be x squared dx. Okay, and from here, we're going to just simply take the derivative of natural log and the antiderivative of x squared, and so this becomes 1 over x dx. And the antiderivative of x squared dx is just x cubed over 3. And so now, performing our nice, fun integration by parts, mini hourglass, time glass thing, whatever you call it, we have natural log of x times x cubed over 3 minus the integral of x cubed over 3 times 1 over x. We can think about it as x cubed over 3x dx. And then I'm going to go ahead and pull out this 1/3 because it's a constant. And then now we're looking at this integral right here. We can think about this as we have x, the integral of x times x over x dx. One of those x's are going to cancel. We'll be left with an x squared dx. And then the antiderivative, got another touchdown in fantasy. The antiderivative of x squared dx is just x cubed over 3. And so we can't lose our negative 1/3 that we had earlier. So negative 1/3 times that is going to be a negative x cubed over 9. And then finally, putting all the pieces back together, we're going to have our final integral. So the final answer for this is going to be, and I'm also going to rewrite this a little bit nicer, x cubed natural log of x over 3 minus x cubed over 9 and plus c. And this, ladies and gentlemen, is our final answer for part D. Cool. Moving on to part E, we have natural log of x over x squared, so not being multiplied, it's over it. A little bit of a similar problem. It's going to be just a hair different. Honestly, probably a little easier if you can keep some of your signs straight. So again, if you're doing this on your own, go ahead and pause the video now, or keep watching to see how I solve it. So again, I'm going to write my best friend Liate, and I'm going to try and integrate my parts first. You can maybe try U sub. I don't know what you're going to U sub, but you can go for that. Going to write our U, our du, our v, and our dv. And so again, L is logarithmic. That's the first thing that comes up in my Liate. You don't have to use this. This is something that I like to use just to help give me better choices. And so for u, I'm going to pick natural log of x, and for dv, I'm going to pick 1 over x squared dx, because this is a 1 over x squared if you want to think about it like that, as in terms of a product. Got some stuffy sinuses. So now we're just going to simply take the derivative of the natural log of x, which again is 1 over x dx, and the antiderivative of 1 over x squared. I'm going to think about this as an x to the negative 2, and then I'm going to do my reverse power rule. And so the antiderivative of x to the negative 2 becomes x to the negative 1, and I bring this negative 1 down forward, and that's a negative x to the negative 1. All right. Hope that this part kind of can kind of confuse some people, that little algebra rewrite. So I just rewrote 1 over x squared as x to the negative 2 using powers of exponents. And then I added 1 to the top, and so negative 2 plus 1 gives me a negative 1. And then I bring that down forward, and I get this negative sign right here. Okay, cool. Now time to do our integration by parts formula thingamajiggy. We're going to have natural log of x times negative x to the negative 1. We'll rewrite that later. minus the integral of negative x to the negative 1 over x. This we will go ahead and probably rewrite. These negatives are going to cancel out, giving us a plus, and this x to the negative 1 we can think of as 1 over x to the 1. And so, we can rewrite this as 1 over x times 1 over x, just by bringing this negative 1 down, and then just the invisible 1 over x right there. And so then when we're multiplying by exponents, we're just going to add them, so it's going to be the integral of 1 over x squared dx. And so I'm just going to... Cool. And then from here, we can rewrite it again. I guess we could have just brought this up top in the first place, but I'm going to write this as the integral of x to the negative 2 dx. And then just like we did right up here, we're going to have a simple antiderivative to do. And that's going to be x to the negative 1 negative. And then from there, we're just going to put in the rest of the stuff that we missed. And so rewriting that, we're going to get a negative natural log of x over x minus what that just was, minus 1 over x plus c. And let's go back up, and I know that was kind of a weird problem. There's a lot of negative signs written around. Just got to make sure that you're keeping track of them, and also make sure you don't forget about your piece before from the u times v integration by parts formula. That can sleep away from you. And this plus was a minus, but then we canceled it out with two minuses right there. So do we get plus c's and everywhere else so far? Hope no one was yelling at me. Okay, we're good. All right, last problem. Again, pause the video now if you want to try on your own. If not, I'm going to jump right into it. So first off, I see this minus sign, so that means I can go and rewrite this in terms of two integrals. And then I'm going to make sure you use parentheses here just to be certain that this minus is going to the whole part. And I'm going to go ahead and split this up algebraically into an integral of x over x squared plus 1 and a 1 over x squared plus 1. And that's a perfectly legal rewrite. I think it's going to make our life a little bit easier. So the first one, we have x over x squared plus 1 dx. And then we have plus the integral of 1 over x squared plus 1 dx. Hopefully, the first and the last one are kind of yelling at you for something. The first one, we're going to have natural log, absolute value of x. And the last one, we're going to have arctan of x. Again, this is really key about knowing those just common inverse trig functions, antiderivatives. And so arctan, again, is going to show up everywhere. And so now we have almost all of our pieces. We're just going to need to figure out this bad boy, and then we'll plug it in here. So I'm going to go ahead and copy this whole thing. Let's go ahead and, I got a little extra piece there we don't really need. Let's go ahead and work this out down here. Whoa, what's happening? Okay. I'm going to look at this, and my eyes get fixated on the degree of x. As you can see, it's x to the 1. And so I know when I take the derivative of x squared, I'm going to be left with an x to the first something. And so this is a good choice for a u sub of u equals x squared plus 1. That's going to make du 2x dx. And then I see we have not a raise. I see we have an x dx up top, and I have an x dx right here. So I need to get this x dx by itself, and I have to do that by dividing by 2. And so now I'm left with the integral of, but in the u world, because the u world's super fun. Let's not lose our 1/2 that we just got from dividing by 2. We know our du just got soaked up into the x dx, and left with 1 over x squared plus, or 1 over u. Don't want to do that. That's a common mistake. So, and then we know the antiderivative of 1 over u is natural log. So we have natural log absolute value of u over 2, and in this case our u is natural log of x squared plus 1 over 2. And we're going to put all of our pieces together. And finally, we are going to be left with all of this, but with this negative distributed inside. And so our final answer is going to look something along the lines of this. I'll just rewrite it down here. Natural log absolute value of x minus 1/2, or you can put then at whatever. Natural log absolute value of x squared plus 1 over 2 minus arctangent of x plus c, and that is the final antiderivative of this video. Thank y'all so much for watching. I hope this really helped. Some of these can be pretty tricky, but really knowing some of your fundamental derivatives and maybe some tricks or shortcuts on some of the integration techniques is really going to help. As always, thanks for watching, and I believe in you.